Okay, I want to talk to you about electrolytes. So first off, what is an electrolyte? An electrolyte is some substance that conducts electricity when dissolved in water. So any kind of substance that will conduct electricity when it's dissolved in water is considered some sort of electrolyte. Whereas if you had something that when it's dissolved in water, it did not conduct electricity, that on the other hand would be a non-electrolyte. So you have electrolytes and you have non-electrolytes. But we can get a little more specific than that. We can actually break it down into strong electrolytes, weak electrolytes, and non-electrolytes. So things that conduct electricity when dissolved in water can do so very well or just very weakly. And so that's our distinguishing between strong and weak electrolytes. So let's look at each one of these a little bit closer. So strong electrolytes, of course, are very conductive. Okay, so we take this substance, we dissolve it in water, and that solution conducts electricity very well. So if we had this experimental setup where we have a light bulb and we have, you know, the wire that's going to provide the electricity in two pieces to where it needs to be connected in order to, complete the circuit. And so if you then dip that into that solution, if that solution contains a strong electrolyte, it'll conduct electricity really well and it'll light up that light bulb. Um, and so the reason that this would happen is because within an electrolyte solution, there's ions, okay? And those ions allow the ease of flow of the electrons through the solution. So if you have a strong electrolyte, that means that that substance, when it's dissolved in water, it produces a lot of ions, okay? And so typically those ions come from that compound, whatever it is that you put into water, splitting up into ions, whether it's, ionizing or dissociating. Depends on what kind of substance you're starting with. So if you're starting with an ionic compound that's already made up of ions, so all that needs to happen is those ions kind of break apart. So that would be dissociating. Whereas you can have other compounds that are covalent type compounds that don't really contain ions already, but once they're put in water, some of them will create ions, and that's called ionization. Um, so for any strong electrolyte, you're going to have lots of ions in solution. And it's helpful to be able to predict whether or not a substance will behave as a strong or weak electrolyte or even a non-electrolyte when it's put in solution. So I've got a list here of the things that behave as strong electrolytes, and that would include soluble salts, strong acids, and strong bases. So any salt or ionic compound, in other words, that it is soluble, meaning it's something that dissolves completely, um, that is going to create a lot of ions in solution. Thus, it will conduct electricity very well. Thus, it acts as a strong electrolyte. Similar strong acids and strong bases will also produce a lot of ions in solution. Acids always start as a covalent compound, but when they're put in water, they ionize, and so they split into ions. Um, and if it's a strong acid, it completely splits up into ions, or at least ions it's capable of producing. Whereas your bases, a base could be an ionic compound or a covalent. You have both types. And so it could be that it just splits up into the ions that are already there, or it creates ions in solution. Typically, the strong bases are all of the ionic type. And so those are possibilities of things that are strong electrolytes. Now, it may be difficult to just look at, the formula of a compound or the name of a compound and know, is that one of these classes of compounds? So that's another task that you have to be able to do that I'll talk about in another video. But if you're directly told that this is a soluble salt or a soluble ionic compound, or it's a strong acid or a strong base, then you should know right away that that is a strong electrolyte. Now, weak electrolytes, it's very similar. They conduct electricity, but only slightly. Okay, and so if you had this same setup, it would still light up the bulb, so it would allow electricity to flow, but just not as much. And so the bulb would be kind of dim when it's, those wires are put in that solution. Now, that is because in a weak electrolyte solution, you get only a few ions in solution. And so the substances that are put into water only partially break up into ions. And so this can happen when you put insoluble salts into water, or if you put weak acids or weak bases into water. Okay, because all of those things, they do produce ions in solution, but not completely. So only a portion of what you put into water and what dissolves, only a portion of that produces ions. Okay, so the insoluble salts, we use that term insoluble, and typically people would think that means that it doesn't dissolve at all. Really, an insoluble salt is always going to partially dissolve, but so little of it does, we classify it as insoluble. So salts, again, that's kind of a generic name for an ionic compound. So if you have an ionic compound, if it's insoluble, it's still a little bit of it breaks up in solution. You put it into water and most of it stays solid, but a few ions break free. And so those few ions that are floating around then in that solution can conduct electricity. Similarly, your weak acids and weak bases, you put these compounds into water and a few of the molecules or part of that sample will release some ions, whereas the rest will remain as kind of their neutral starting point. Okay, so those solutions just have a few ions. And again, you may not already know how to determine, is this an insoluble salt or is it a weak acid or weak base? But that's something that eventually you have to learn. But at first, if you're just told this is an insoluble salt, what kind of electrolyte is it? You should know it's a weak electrolyte because they always are. Same with weak acids and weak bases. Okay, lastly, the non-electrolytes. So remember, your non-electrolyte's kind of the opposite of an electrolyte. It is something that does not conduct electricity when it's dissolved in water, so it is not conductive, and that is because there's no ions in solution. Now, that is a slight lie. There could be a very small amount of ions, not very small in the sense of a weak electrolyte, but so small that we kind of say that there's no ions. Okay, so really like pure water, if we just have H2O, okay, so just H2O molecules with H2O molecules, technically there are some ions in there, but there's so few, it's not enough to conduct electricity. So even though there are a few, it's classified as a non-electrolyte. Okay, so just to keep it simple, your non-electrolytes are any neutral molecular compound. Okay, and when I say neutral, I mean non-acidic and non-basic. Okay, not neutral in the sense that it has no charge, because all molecular compounds have no charge. Otherwise, we would call them ions. Okay, so water is a neutral molecular compound. It's not considered to be acidic or basic on its own. And so it's a non-electrolyte. Same would go for like CO2. You can dissolve CO2 in water. And in general, then we would consider that a non-electrolyte. If you dissolved, say, sugar in water, that's a molecular compound and it's not an acid or base. And so that also would be a non-electrolyte. So at first, it can be kind of challenging to identify, is this compound a strong electrolyte, weak electrolyte, or non-electrolyte if you don't know what class of compounds it falls into. But to get started, you should at least be familiar with the basics of, I have a soluble salt or an insoluble salt, or I have a weak acid or a strong acid or a neutral molecular compound. Where does that fall with respect to electrolytes?